I'm Nicholas Wells for Keystone Learning Systems. In this course, Red Hat Linux System Administration, Level 1, will introduce the Red Hat Certified Engineer program to you and then walk step by step through a Red Hat Linux installation. We'll talk about booting the system and shutting it down. Then we'll look at some additional configuration options for the Lilo Boot Manager and the graphical configuration. In this section, we'll review some background information about Linux and talk about the Red Hat Certified Engineer program. You're probably aware that Linus Torvalds began the Linux kernel as a school project in Helsinki, Finland back in about 1991. What fewer people are aware of is the role that Richard Stallman and the Free Software Foundation played in the development of the Linux operating system. Where Linus created a kernel, the people working with Richard Stallman and the Free Software Foundation created the rest of the operating system for the most part, all the utilities. There were others that worked with the X Windows system, the Apache web server, many components that we now think of as a complete operating system. But these two men together were behind most of this work. Richard Stallman also created the GNU General Public License, or the GPL. This is the license that Linus Torvalds decided to license the Linux kernel under. Linux is still a trademark and is still copyright by Linus Torvalds, but he releases it under the GPL. We sometimes call this the open source license. Part of the GPL, or the open source license, indicates that the source code to the operating system, the kernel in this case, must be included with the operating system. So whenever you get a copy of Linux, you have the source code to the kernel, as you'll see later in the course. Another feature of the license is that anyone who enhances the source code must share those enhancements with everyone else. This allows Linux to grow rapidly because everyone is contributing to its features. Now, there are many companies that put together a complete Linux distribution, the kernel, the utilities, the graphical portion, all these different components. Red Hat Software is one of those companies. It's been around for about 6 years now. You may have heard of others, Slackware, Debian, Caldera Systems, SUSE. They're all quite similar, but Red Hat right now is the market leader, and we're going to focus this course on the information for Red Hat Linux. Red Hat Software, like many other companies, works with many different products that it takes off of the internet and combines into the official Red Hat Linux. These products have many different licenses, including the GPL license that was just mentioned, and different licenses for the Apache web server, the X Windows system, and the Berkeley license, just as 3 examples. Red Hat Software tests what it sells, so you have some certification kind of to know what you're getting on your CD. Red Hat also provides technical support, contracts and telephone support, and of course they have training and certification programs available to let people know that you know about the Linux software. The core of the Red Hat training and certification program is the RHCE program, the Red Hat Certified Engineer program. This program consists of several courses. The first, RH033, an Introduction to Red Hat Linux, followed by 133, System Administration, followed by 253, Network and Security Administration. Now, after you've taken those 3 classes from Red Hat, you can take the RH302 certification test. If you're already experienced with Linux, you have several years of experience, you may choose to take a different path. You can simply take the RH300 Red Hat Certified Engineer class. This is a 5-day course with the certification test coming at the end. You should consider this course as effective training for the 133 System Administration course. Now, this isn't an exact duplicate of what you would find if you sat through a 4-day class, but the system administration principles are basically equivalent. Now, let's talk about the test. You don't want to take the RHCE test unless you have some hands-on experience. We're going to go through a lot of very detailed system administration work, but you'll actually want to sit down at your Red Hat system and go through, do some practice exercises before you invest $700 in that certification test. You can take the RHCE test either as a standalone 302 course or as part of the 300 course. It would be the last day. In either case, it's a 6-hour hands-on test. The first portion is an installation test where you sit down in front of a computer with your CD and some instructions, and you have to install Red Hat with some certain specifications to follow. The next portion of the test is 2 hours of multiple choice questions about different commands, different methods of system and network administration. And finally, the last portion is troubleshooting. You are given a system or put in front of a system that has several things wrong with it, and you're asked to troubleshoot and fix those problems. And then someone looks at how you've set up the system, the configuration files, all the things that you've done, and grades you based on your knowledge of the system. I'll assume that you have some background with Red Hat Linux as we go through these system administration topics. This would be equivalent to the previous Introduction to Red Hat Linux course from Keystone, or if you have equivalent experience having installed Red Hat Linux, played with it a little bit, you'll be fine as we go through these more advanced topics. The topics that you'll find outlined for the RH133 course on the Red Hat website, and which we'll cover in this course, include the following. We're going to carefully walk through the installation of Red Hat Linux. We're going to talk about some basic configuration options and tools that you can use. We're going to look at the initialization process, how the system starts up and how you can control that process. We're going to look a lot at file systems, how you can add them to your system, configure them, troubleshoot them. We're going to look at setting up users and groups, accounts, managing those accounts. We're also going to look at processes, how they run on Linux and how you can control them. We'll look at the Linux kernel, including recompiling the kernel. We'll talk about some general troubleshooting tips. We'll look at printing. We'll talk about how logging is done on Linux. This is an important part of troubleshooting and security. And finally, we'll talk about some basics of networking and security. In this section, we've looked at the background of Linux, of Red Hat software, and of the RHCE certification program. We've also looked at the different topics that we'll be talking about in this course. In the next section, we'll look at some basic concepts related to the Linux operating system. In this section, you'll learn some basic concepts about Linux, such as how it works with different devices, how processes within Linux communicate with one another, and how Linux compares with some other operating systems. You can think of a complete Linux operating system as made up of several parts. At the core of the operating system is the kernel. The kernel provides the most basic functionality, such as scheduling different processes, allocating memory, controlling devices, and things like this. On top of the kernel are device drivers that actually interact with pieces of the hardware as controlled by the kernel. Now, what you normally think of as what you see in Linux is the running programs. These programs interact with the device drivers and sometimes with the kernel itself. Now, a special version of a running program or a special instance is the shell. This is the command line environment. It's not actually different than other programs, but we have a special relationship with the shell because it allows us to enter program names and run programs so that they execute with the kernel. Each of those programs will have some kind of user interface. It may be a graphical user interface, or it may be text or character based. Now, there are actually some programs called daemons that are background processes or programs. They do not have a user interface. You'll learn a lot more about those in a future section. Looking at some of the features of Linux, it is a multitasking, multi-user operating system. Many processes or user programs are able to run at the same time. Now, they're actually not running at the exact same time. The kernel is doing what's called time slicing and switching between them, or context switching, between multiple programs very rapidly, and so they appear to run at the same time. Linux uses what is called preemptive multitasking. In preemptive multitasking, the kernel always has control of all the programs and will take back control when one program has run for a certain amount of time. The alternative to this is cooperative multitasking, in which a program has to relinquish control, and in this case, if it doesn't relinquish control, the operating system can crash. So it's fortunate that Linux has preemptive multitasking. It aids its stability. Linux also has support for multiple CPU computers. In this case, a single CPU may be running one process while a second CPU is running another process. Linux also supports multiple user accounts. Now, these are generally network accessed, that is, people will log in across a network connection so that you have many people logged into the system at the same time, each one of which can be running multiple programs. Because the Linux kernel had these features built in from the beginning, multitasking, networking, multi-user capability, it's a very stable, secure system. This is very different from some other operating systems which had networking or multi-user capability added on as an afterthought or after years of development. Let's look now at some of the differences that you'll find in Linux in file systems and devices compared to some of the other operating systems that you may be familiar with. If you've used a lot of different operating systems, you may find working with file systems in Linux to be kind of unusual. There are no drive letters in Linux. Instead, we access parts of the different file systems that we want to work with from a single location called the root of the file system. This is a directory that we call / or the root directory. All of the other file systems that you may want to access, whether they are local file systems such as a CD-ROM or a floppy disk, or remote file systems, things that you want to access across the network, are all accessed as a subdirectory of the root file system. An example of this is how devices are accessed. They are also accessed as file names within the root subdirectory. Most of the devices that you'll work with in Linux are stored as a file name within the dev directory, or /dev for devices. There are two different types of devices in Linux. You have block devices. Hard disks are an example of block devices. They transfer information between the device and the operating system in blocks of data. A standard Linux block is 1024 characters or bytes. There are also character devices. An example would be a serial port. These devices transfer information one character at a time. Although Linux began in 1991 and has been widely used since about 1994 when version 1.0 was released, you may not be familiar with how it compares in some ways to the more widely known operating systems such as Windows NT or commercial versions of Unix. Let's look at just a couple of points of how Linux compares with those other known operating systems. If you're ready for some gross generalizations, let's talk about Linux and Windows NT. Linux is considered by many people to be a more stable and a more secure operating system than Windows NT. Part of this is because of its development model, the open source model, and also because it's based on the Unix operating system, which has been around for about 30 years and is also considered more stable and secure than Windows NT. Linux can work without a graphical interface, whereas Windows NT always uses the graphical interface. Now, if you prefer the graphical interface, this may be a detrimental part of Linux, but it allows you to remove that portion of the operating system and save those resources when you're using Linux for a system that does not need the graphics, such as a server that's being stored in a closet somewhere. Now, to be fair, Linux does have fewer applications than Windows NT. We hope that'll change, but that's still the case. Now, looking at Linux and Unix. Linux was designed as a version of Unix. Unix being designed many, many years ago. Linux was developed independent of the commercial Unix systems, however. It doesn't use any of the software or the code from the Unix systems that you may have heard of, such as SCO Unix, IBM AIX, HP UX, systems like this. Linux is a combination of the features of both the Berkeley version of Unix and the AT&T version of Unix. It's been said that the user interface capabilities of Linux and the utilities that you'll use are more like BSD Unix, whereas the organization of the file system and some of the initialization and scripts, things like this, take more after the System 5 version 4 or release 4, SVR4 AT&T Unix. However, if you know Unix, the fact is you'll have a very easy time learning Linux because they're very similar. In this section, you've learned some basic concepts about Linux, how it compares to other operating systems, and how it works with file systems and devices. In the next section, we'll begin preparing for an installation of Red Hat Linux. In this section, we'll get down to business and start installing Red Hat Linux. We'll look at some of the prerequisites, how you need to set up your hardware, and then we'll go ahead and boot into the installation program and walk through it step by step. Before you install Red Hat Linux, the first thing you'll want to do is make sure that the hardware you want to install it on is compatible with the operating system. Now, I've logged on here to the redhat.com website, and down in the support section, they may rearrange this from time to time, but in general, under the support section, you'll find a hardware compatibility link. So I'll click on that. And as that loads, I'm going to go down here and I'm going to be installing Red Hat Linux version 6.1. It doesn't change a lot between versions, but you'll want to get the latest that there is, of course. And we have here a hardware compatibility list. Now, the hardest part may be locating or determining what the hardware is that you actually have on your system. If you're not buying a new system and you don't have the manual, it can be hard to find these things out. You don't want to end up opening the system and looking at the chips to try and determine these things, but sometimes that's what's required. Most of the CPUs or system boards that you'll have will be supported, as will standard disks, IDE disks. When you start looking at SCSI adapters, video cards, network cards, especially if they're high-end or very new hardware, you'll want to check in these lists and find out if they're supported. Tape drives, video cards are where I seem to have the most problem because they're coming out with so many new cards and they're so difficult to configure anyway. The product that comes with RedHat for the video configuration is called X386. That's the video server. Now, the different versions of X386 support different numbers of cards. A later version than this has been released but isn't included with version 6.1 of RedHat. So you may have a later version that you can look at. Then you can go down and look either for the brand name, such as a Diamond Stealth card, or the chipset. You'll find some video chipsets listed here as well. S3 chipset, some Trident or Chips and Technologies chipsets, things like this. Networking cards are also listed by category. And then there are a lot of other types of hardware, sound cards, mice, modems, where you're not likely to have a problem. But again, if you have a high-end system that you really want to make sure that the sound card functions well, or that the printer is supported with all of its special features, you'll want to check this list and see that it's there. Not many people are using radio cards, but there's a list of what's supported. PCMCIA for your laptops is an important consideration. Not all PCMCIA cards are easily used with Linux, although most are supported. Now, this laptop item deserves special consideration. The special hardware that manufacturers include with laptops, including the video card, the way the mouse is configured, the network card, they make it very difficult to install Linux in some cases. Now, some laptop manufacturers, including Toshiba, Dell, and Gateway, have announced that they're supporting Linux, and you may be able to buy a laptop with Linux pre-installed. But there's a website that you can go study if you have a laptop that you already own and you want to install Linux on it without problems. I've gone to a search engine here, and I'm going to enter Linux laptops, and I'll get a list of resources to help me learn about loading Linux on a certain laptop. The page that I usually go to, the Linux on Laptops page at the University of Texas, is located right here. There's some other resources as well. This is a long URL, so I don't try and memorize it. You can see it up there. This is just a user at that site that's maintained this listing of information for installing Linux on laptops. But it has a huge list of models, manufacturers and models, and when you choose one of those, for example, let's go down to Toshiba Satellite, maybe a 2595. This links to an individual who has installed Linux on this laptop, created a page about it, and then submitted that information back to this central site to allow other people to use this information. You can see we have information on the basic installation, setting up X386, the graphics card, getting sound to work, potential problems with PCMCIA cards, and very useful information, a sample configuration file. Rather than just telling us about how to do this, all we need to do is copy down this configuration file. Now, not every laptop is going to have all this information. They're all a little different. But you'll find a lot of details about using the different versions of laptops with Linux. And as you can see, this is a very long list. Once you've made sure that your system is compatible with Red Hat Linux, you need to answer a couple of other questions. The first is, where are you going to install the system from? Now, you probably have a Red Hat Linux CD-ROM, in which case you could install directly from the CD-ROM. In some cases, you'll want to use other installation methods, though. Most people will simply copy the operating system from the CD-ROM that Red Hat provided onto their hard disk. You can, however, copy the contents of the CD-ROM onto a hard disk, maybe a different hard disk partition or a separate hard disk from where you want to install Red Hat, and then install from one hard disk onto another. If you're installing many systems, or if your local computer doesn't have the hardware that you need, you can put the CD-ROM or copy the CD-ROM onto a hard disk on another server, and then install the system over the network. This can be done either using the NFS protocol for network file system or using the SMB protocol. For example, you could put the CD-ROM in the CD-ROM drive of a Windows NT server that you have on the local network and then install it using the SMB protocol on your local system. The next big step in preparing for the installation is to prepare your hard disks. Now, Linux needs to be installed on its own separate hard disk or on a separate hard disk partition. Now, it's not uncommon for you to share a single hard disk between a Windows system and a Linux system. This is called a dual boot arrangement, and then you can choose which operating system you want to launch each time you turn on your computer. In order to do that, you still have to create a separate partition for Linux. There's some tools that are included on the RedHat CD that will allow you to do this, but first you need to think about what partitions you want for the RedHat system that you need to install. You have to have at least a root file system for the Linux operating system. We call this /, as I mentioned, the root of the directory structure, but it's also called the root file system. In addition to this, you'll probably want a swap partition. The swap space or swap partition is what the Linux kernel uses as virtual memory. This is a space that can substitute for RAM memory and allows the kernel to swap out to disk or move to the hard disk portions of an application that is not being executed. It's pausing or sleeping. This allows it to make more efficient use of your memory. The swap space can be large or small depending on the type of system that you're working with. A common size might be something like 64 megabytes. You may also choose to set up other file systems or other hard disk partitions that are subsystems or subdirectories of the root file system. If you're accustomed to thinking in terms of drive letters, this may be an unusual concept. Suppose that you have a subdirectory called /home where the home directories of all the users on your Linux system are going to be stored. You can place that home subdirectory on a different partition or on a different hard drive if you choose. There are many reasons why you might choose to do this. For example, you might only back up the home directory at certain times on a different schedule than the rest of the operating system. You might mount this partition or this subdirectory in a different way, allowing certain security features or allowing certain capabilities to the users that were not permitted with other parts of the operating system. On a very large Linux system, one that had maybe multiple gigabytes, 10 to 30 gigabytes of data, it wouldn't be uncommon to have the file system, the directory structure, divided into multiple partitions. You might have a /home subdirectory, /usr, /var, these are different subdirectories, all stored on different partitions or even different hard disks. Here are a few of the subdirectories that system administrators would commonly choose to put on a separate partition or even a separate hard drive. I've listed a short description of each of these directories, and you can determine based on how large your system is and how it will be used whether you think it would be useful to have these designed onto a separate partition. To prepare these partitions that we're talking about, you can use the fdisk utility, that's for fixed disk utility, within the installation program of Red Hat Linux. You'll see that as we go on. If, however, you need to create a dual boot system with an existing Windows operating system, you should use the FIPS program, that's FIPS, that's included on the Red Hat CD. This will allow you to take a single Windows partition and create a second empty partition that's just free space that you can use to create Linux partitions during the installation. Now, if you have a commercial product like Partition Magic, obviously you can use that as well to shrink and rearrange your Windows partitions. The next step is determining how to launch the installation program. This is normally done either by simply booting the Red Hat CD. It's a bootable CD if you have a bootable CD-ROM drive. You may need to turn that on in your BIOS settings. Or you can do what I'm going to show here, create a boot floppy and then reboot the system from that floppy disk. Now, I've jumped ahead a little bit. I'm sitting here in a copy of Red Hat Linux 6.1 and I'm going to create the boot disks. Now, you could do this from a Windows system or another Linux system if you choose. I have the CD mounted so that I can go to MNT CD-ROM. Now, if it doesn't happen automatically for you, you can use this command to mount the CD-ROM, making it accessible, but I didn't need to do that. So within this subdirectory, I'm actually looking at the contents of the CD-ROM. I'm going to go, well, first let's look at the DOS utils subdirectory. Under DOS utils, you'll find the FIPS utility that I mentioned, which will allow you to resize a Windows partition, allowing free space where you can install Linux. There's also a utility here called rawwrite. This is the utility that you would use from Windows or DOS to create the floppy disks that I'm now going to create within Linux. So I'll go back a directory and over to Images. So I'm just in the Images subdirectory of the CD-ROM. You can see the contents here, 4 files. We have 3 image files. Each of these is an exact copy of what you would find on a floppy disk used to boot the system or work within the installation. Now the 3 different images are important. Normally you would use the boot img file to just do a normal installation. If you're working on a laptop and you need to access the PCMCIA cards to complete the installation, then you would need to create this as well. It would be requested during the installation. Switch to this disk to go on, sort of thing. If you're going to be installing over the network using an NFS server or an SMB type server, as I mentioned, then you would want to use this to boot the system instead of this. So if you're using a laptop to work over the network, do the installation via a PCMCIA card, then you would boot with this and have this inserted as requested during the installation. So I think that covers all the options. I only need to create this disk because I'm installing from a local CD-ROM, so I don't need the network, and I don't need to access the PCMCIA card in order to access the CD-ROM, which might be the case if the CD-ROM were attached to a SCSI device that was using a PCMCIA card. So I only need this one disk. To create it, I'll use the dd command within Linux. The input file that I'm going to use is boot.img, and the output file is devhd0. That's my floppy disk drive. I'll press enter and that'll get started. This is an unusual format for a Linux command. We don't have hyphens before the options, which we normally would, and we have an equal sign instead of a space for the value of the option afterwards. So be careful with that format. Also be careful not to reverse the input and the output, or you might wipe out parts of your existing system. This will take a few minutes to write, depending on the speed of your floppy disk, and then you'll see an indication here of the number of sectors or records that have been written out to the floppy disk. Once that's finished, you're ready to reboot your system from the floppy disk or from the CD-ROM, and we'll go right into the installation program. Beginning with version 6.1, Red Hat Linux has introduced a full graphical installation. This would be a mouse-based, menu-based, very easy installation method. However, I'm not going to show you that method for a couple of reasons. First, the text-based installation goes through more steps, and you'll learn more about the installation process and what's going on behind the scenes. Second of all, the graphical installation doesn't work on any system I own. I don't consider it stable enough for you to rely on that. Let's reboot the system now and get started. When you boot off of either the CD-ROM or the boot floppy, the boot.img floppy that I created, you're going to see this initial screen. Now, if you want to try the graphical install, which will be very similar to what I'll walk through here, you should understand it without any problem, just press enter. Or if you wait long enough, it'll go in automatically. Let's look at a couple of these other screens by pressing the F keys that are mentioned at the bottom of the screen. I'm going to press the F2 key, and you can just read some basic information about Red Hat. The F3 key is some information about the expert mode, which we won't get into here. The F4 key is about the kickstart mode. This is an important feature of Red Hat. You can create a kickstart disk which has all of the details about how the installation should be done, and if you insert that disk and do the kickstart mode here, as described in this screen, you don't have to press another key during the installation. Of course, you'll only want to do this if you're familiar with what's on the hard disk, or if you've installed on an identical hardware machine previously so that you save that information. But it's a great feature if you have a large lab full of systems to install. Now I'll press F5 for the kernel parameter help. We'll talk about this in more detail later. Basically, by typing the name of the system that you want to start, Linux, and adding a parameter to it, you can send information to the kernel that will modify how the kernel behaves. Now the example that you see here, mem equals 128M, this causes the kernel to recognize that you have 128 megabytes of memory. Sometimes the kernel will not recognize that, will not use all of your memory unless you give it that parameter. Now, of course, this would be part of the configuration after the installation was complete, so you wouldn't have to put that in every time you turned on the system, but this is how you can pass in that information. Now I'm going to press F1 and go back to that main screen, and as you can see in the second bullet there, I'm going to type text and press enter to begin the installation. Now if you're using a boot floppy, as I am, you're going to have to wait a couple of minutes for the information from the floppy disk to load. Most of the disk drives are fairly slow. Then it will begin the screens, locate the CD-ROM, and you'll see the screen change. Even if you started the installation program by booting your CD-ROM, you'll want to have a floppy disk available as you do the installation. You'll use this disk to create a boot disk during the installation that can be used to rescue your system if some emergency occurs and you can't boot it normally. You'll see this option during the installation, but have the disk handy. Now we're ready to go back. The system is booted up, found the CD-ROM, and we're into our installation program. The first screen lets you select which language you want the installation done in. Red Hat has support for many languages. They're a worldwide company. We'll just stick with English in this case. But let's look at how to navigate these screens, because the same type of screen is used throughout the installation. At the bottom of the screen, you can see a description of the keys that are used to do this. If you press Tab, you switch between elements. In this case, there are only two, the list and the button, so Tab goes back and forth. Shift-Tab just does the same thing. And as it says, Alt-Tab will do the same thing. Now, in some screens, you'll need to select an element from a list. You can use the space bar for that. And to go to the next screen, to continue with the installation, you can either press the F12 key if you have selected and everything set up the way you want it, or I usually end up tabbing down to the OK button and pressing enter. Either way will work. We have a US keyboard attached to this computer, so I don't need to make any changes there, but you can see you have many keyboards to choose from. Go back to US, and I'll press F12 to go on. And now we get our welcome screen. There's a manual available if you've purchased Red Hat Linux. If you have a free CD or if you've downloaded Red Hat Linux and cut a CD, you'll just have to deal with the installation program without the manual. We'll press OK to go on. What type of installation do you want? If you know that you want a basic Red Hat installation, you can choose either KDE, GNOME, or server installation from this menu and save yourself some of the steps that we're going to go through by choosing custom installation. The custom selection lets me choose which packages and which types of services I want for my Red Hat system. Now if you already have Red Hat installed, you can choose upgrade, and it will go through and upgrade the packages on your CD or on your hard disk without erasing the information that's already there. If you're not familiar with these, GNOME and KDE are two different graphical desktop environments. I'm going to choose custom, and I'm going to install both of them. I'll choose OK and go on. Now this is the most difficult part of the configuration. We have here a list of our hard disk partitions, their sizes and types, and then further down on the screen you see a list of the hard drives that we have on this system. We only have one here, so there's only one line, HDA. Now this is a device specification method that Linux uses. When you've finished installing the system, if you go to the /dev subdirectory, you'll see HDA, which refers to the first IDE hard disk, or let me tab up to the top of the list, if I can get up there, okay. You'll also see devices HDA1 through HDA16. These refer to the individual partitions on the first IDE hard disk. Now if you have a second IDE hard disk, that would be HDB. And if you have SCSI hard disks, they would be SDA, SDB, and the individual partitions, SDA1 and so forth, numbered for the partition number. Now, because of a restriction in the BIOS, or the ROM, of a standard PC, you can only have 4 regular partitions. You can use extended partitions to have up to 15 or 16, but on my system, I only have the standard 4. You can see the size that I have configured, and then a type over on the far right. The system that I'm working on has a Linux swap partition and 2 Linux native partitions. I actually have 2 versions of Linux installed on this system. So what I can do here, just to show you, is I'll select this HDA3, my third partition, using the arrow keys, and then I've pressed the tab to select delete. I'll delete that partition. I'll press enter to choose yes, and then I'm going to tab back up to the list. You can see on the far left the flashing cursor indicates to you that that is selected, and then you can use the arrow keys to go back up. Now I'm going to tab down to delete again and delete my swap partition, and I'll choose yes. Now I only have the two partitions. Now, assuming that your disk is set up something like this, you have a bunch of free space now that's not allocated to hard disk partitions. You can go down, tab to the Add button, press enter, and now you can add the different partitions that you need. I'm only going to use a swap partition and a root partition. I'm not going to use multiple partitions for /home, /USR, and so forth, but you could do that very easily. The mount point that I'm going to define, therefore, is simply / for the root. The size that I'm going to use is 1,000 megabytes or 1 gigabyte. If this is the last partition that you're defining, then you could click or press the space bar to select Grow to Fill Disk. Now I have to still create a swap partition, so I'm not going to select that. Here I'm going to choose the type of the partition. Linux native is the default. We'll learn a lot more about that later on. That's the ext2 partition type or file system type. You have just a couple here. Linux native is what I want, so I'll tab down to OK, press enter, and it's created that partition for me. Now, it's created it as an extended partition, HDA5. It's a logical partition, but that'll work fine for us. Now I'm going to tab down, I'll tab down to the Add button again, press enter, and now I need a swap partition that does not have a mount point, as we'll see. I'll make that 128 megabytes, and I'll choose swap for the type. Notice the mount point goes away because the swap partition is not accessed as part of the directory structure from / and a subdirectory. It's only accessed directly by the kernel. I'll tab down to OK, and now I have all of my partitions set up. Let me tab back up to the list so I can use the arrow keys. This will be my root file system, and this will be my swap partition. If you're using the graphical installation, you'll see a tool very similar to this that lets you choose the size and type of each of the partitions that you want to define for your installation. If you have multiple hard disks, you'll see them listed at the bottom of the screen. When you tab down to that list and use the arrow keys to change which hard disk you're looking at, the partitions that are listed in the top of the screen will change. You can use these different lists to define multiple mount points for different subdirectories, even multiple swap partitions, which will be automatically added into the system and used by the kernel. Now, one other point about defining these things in the installation program. I've been modifying a partition table in memory, but I haven't written it out to the hard disk yet. When I choose OK and go on to the next screen, the information that I've specified here from my partition sizes, types, numbers, that's all going to be stored on the hard disk, but not until then. So you can cancel the whole operation at this point without having written anything to your hard disk. But let's go on with the installation. Now, if you get confused during the editing of this partition table, you can press the F5 key, as you see at the bottom, and reread the partition table in its original form from the hard disk. But I'm going to press the OK key to go on. And I'm going to choose yes to save the information to the partition table. Now, on some systems you may want to reboot if you get a message saying that you should restart the system so that the partition table is correctly read from the hard disk. It's not as much a problem as it used to be. We're not getting that message, so we're just going to go right on. The installation program is only finding one Linux native partition that has a directory associated with it, and that's the HDA5 partition that we just set up for the / directory. We see that selected here with the asterisk. That's going to be formatted now. If you tab down to this item, you normally don't need to check for bad blocks unless you have a very old hard disk or you're concerned about it because you've had problems. If you choose this with the space bar, it will add a lot of time to the formatting. Normally the formatting is very quick. So I'll leave that off, tab down and choose OK. We're now setting up the Lilo configuration of the system. Lilo is the Linux loader. This is a program that is stored in the boot sector or the master boot record of the hard disk, and it actually loads the Linux kernel and transfers control to it, launches the operating system. Now Lilo is a powerful boot manager. It can also start up other operating systems. On my system, for example, I have Windows loaded and 2 versions of Linux. I can start either of those or any of those using Lilo by simply entering the name of the operating system that I want to start. Lilo can also pass parameters, kernel parameters, to Linux as it boots the operating system. We'll do now some basic configuration of Lilo, and after we've installed Linux, we'll see how you can change that configuration as needed. Most hard disks use 3 numbers to refer to a space on the hard disk: the head, the cylinder number, and the sector number. You can choose this item if your hard disk, because of its arrangement, needs to use what's called linear mode, which gives a single number to each location on the hard disk, but that's fairly unusual. In this field, you can enter parameters, kernel parameters, that you need to pass to the kernel when it starts. For example, if you have 256 megabytes of memory, you can enter this parameter to make sure that that amount of memory is detected by the kernel and actually used. If you put in an amount there that is not accurate, you'll cause the system to crash. So we won't put anything there. My memory is auto-detected just fine. Now we can decide in this screen where we want to install Lilo. One option is the master boot record. Another option is the first sector of the boot partition. This is where the operating system itself is being installed, partition number 5. I normally choose the master boot record because of the way that the system is controlled. When you turn on your computer, the BIOS first transfers control to the master boot record, which in turn will normally transfer control to the active boot partition. If the active boot partition does not contain Linux, then you'll have no way of booting Linux. So by placing Lilo right here in the master boot record, I get control to Lilo immediately from the BIOS, and then Lilo can launch Linux, Windows, or whatever other system I want to use. 2 caveats to be aware of as you prepare your partitions and install Lilo. Some operating systems, such as Windows, will try to overwrite Lilo if it's in the master boot record. They'll try to take over the master boot record to make it easier for you to manage the system, which is great unless you're trying to install Linux as well. Second, the BIOS of your PC has trouble with cylinder numbers on your hard disk larger than 1024. If the partition that you want to boot has a cylinder number that's greater than 1024, it won't be able to launch the operating system, even with Lilo. In this case, you'll need to use some special techniques, such as having a separate partition with the boot information and a second partition with the bulk of the operating system. RedHat documentation has some instructions on how you can do this. Most standard PCs won't have that large a hard disk to go over the 1024 boundary, so you won't have any problems. I'll tab down to OK, and we'll install Lilo on the master boot record. Lilo is going to contain the following items. It's detected that I have a copy of DOS or Windows installed based on the type of the partition, and it's assigned a label to it of DOS, which is fine. There's also another Linux partition, and I could go down and choose Edit and assign a different label to that so that I can boot it. I'll just use Linux 2. If I don't tab down to Edit and I don't put a label on that partition, then I won't be able to launch it once I've installed Red Hat Linux. And going back up to the list here, HDA5 is my standard Red Hat partition where my root file system is. It's assigned the name Linux to that. I could go into Edit and change that to Red Hat or something else if I chose. But that works, so I'll tab down to OK and press Enter. During the installation, you're going to be asked a few questions about the networking configuration for your local network and how you want to attach to that network. Most of this information you'll want to get from the system administrator of your local network. For example, your IP address or information about a DHCP server, if that's how you're getting your IP address, and a host name. Now, the system that I'm working on is a laptop. Laptops are a little particular because I have not used a PCMCIA boot disk. I didn't need to do the installation. The networking cannot be configured during the installation. This works fine because we're going to do the networking configuration in a lot more detail after we finish the basic installation. But you'll see some of these questions come up, and we'll walk through it during the installation itself. The host name is simply a name that you assign to your computer. Now, I get to choose my own. Your system administrator may have one assigned to you based on your location, your username, or what you do in the company. Next, I'm going to choose a mouse, and this is the mouse selection that's going to be used for text mode. That is the type of mode that I'm in now. This does not apply necessarily to the graphics mode. We'll just go ahead and let's go down to there. We're going to choose Emulate 3 buttons. Linux is based on a Unix model where most mice had 3 buttons, and the middle mouse button was used for some special functions. By choosing that option, we can emulate the middle button by pressing both mouse buttons at the same time on a 2-button mouse. The CD is spinning up as we go to the next item, and we'll select our time zone. The hardware clock could be set to GMT, Greenwich Mean Time, or it could be set to local time. If the computer that you're installing on has only Linux on it, then you should check this item and assume that the hardware clock is set to universal time. If you're using a dual boot system with Windows installed as well, then don't select that. And we'll assume that the hardware clock is set to local time. Linux prefers Greenwich Mean Time, but it confuses Windows, so you may not be able to use it. Then we'll tab down and choose a time zone. There are a lot of different designations here of the time zone based on where you are in the world. We're in US Mountain. Next, we enter the root password. The root user is the super user, or the administrative account for all Linux systems. The root user can do absolutely anything on a Linux system. For this reason, you should guard the root password very carefully. The root user can access anyone's files, can destroy the operating system with one misstep. We'll learn how to do that later. Enter the password twice here to make sure that you're typing it correctly, and don't let anyone else get a hold of it. I'll carefully type in my password once, press tab, and carefully type it in twice. Press tab down to OK. You don't even get any feedback for the number of characters, so type carefully. Now, the root account is the administrative account, and so you don't want to be logging in as root for your normal work. It's too dangerous in case you make a misstep and erase something. Also, if you're logged in as root, it's a security risk for network access. So you want to have a regular user account. I usually use nwells, and you'll assign a password to that account. You'll log in using this account for regular day-to-day work. I only need one regular account here. You can add others at this point if you want using the Add button, but you can also add them later on after you've done the installation. We'll do that in another section. Authentication configuration determines how users will authenticate themselves or identify themselves with a certain user account on the system. NIS, the Network Information System, is sort of a shared database of usernames, passwords, and other similar information that you can share on a local network. This has some security issues, and so we don't really use NIS very often. It's a very good system if you have a secure local network. We normally do use both the MD5 password feature and the shadow password features. MD5 allows us to have very long passwords, up to 256 characters, and shadow passwords protects our passwords from easy access by users who are logged into the system. So we'll leave those defaults as they're set and go down to OK. Of course, you can change that authentication information very easily after you've installed the system. The installation program has gathered a lot of details. We'll just have to answer a couple more screens, and then it will actually start applying all of the information that we've entered. What you're seeing here is the package group selection screen. We're doing a custom installation, and so we have to select, of all the different packages, what we want included on our system. As I mentioned previously, I'm going to install both the GNOME and the KDE desktops. I also have to have the X Window system. That's the underlying graphical support. I want to be able to print files. I want some client-side tools to be able to access the web, email, and so forth. I want to be able to connect to DOS and Windows systems over the network. I don't really need to do much graphics manipulation, and I won't have time for games on this system. I don't need multimedia support, but I want some of these servers so that we can demonstrate some of those things. These are different network services that would allow you to have clients connect to your Linux server. We'll leave off the Postgres database server, network management, some of these other tools. I do want some development items and the extra utilities. Everything will make a very large system. That's the all-inclusive item, so I'll leave that off. I'm also going to leave off the extra documentation. You may choose to put that on if you have a fairly large hard disk. I've only given myself 1 gigabyte, which isn't a huge amount of space when you have such a large amount of information on the CD that could be installed. If you choose extra documentation, you'll get the documentation in 10 or 20 different languages. So you may want to choose that carefully. When I tab down to select individual packages, if I press the space bar to click on that, when I choose OK, it's going to go to another level of detail, and all of the items that I have selected up here, for example, all the ones that have a star, it will let me choose within that area the individual packages. I don't need that level of detail, so I'm going to deselect that item. I'll press tab down to OK, and we'll go on. The final part of the configuration that we're going to do is for the video card. The configuration utility that RedHat includes and recommends that you use to set up your video card is called Xconfigurator. That's with a capital X. What we're running here in the midst of the installation program is actually Xconfigurator. But I have never had really good luck with this program. It doesn't seem to detect or correctly configure most of the systems that I work with. We're going to walk through the steps here, but you'll see that it doesn't successfully configure my laptop. After the installation, we'll go back and look at some different ways that you can configure your graphical system. The first step in setting up the video graphics is to select which card you have installed on your system. Now you can see that some of these are brand names and some of the others are chipsets. You can press the first letter of the one that you want to select and it'll jump down in this very long list to the first one that begins with that letter. And I'll scroll down here and choose the one that's installed on my system and tab to OK. Now I happen to have gotten this information from a website for my manufacturer. The selection that we've made for the video card tells the system which video server to install during the installation. We'll finish up that a little later. Now we're being asked if we want to create a boot disk, and the answer is yes, you want to create a boot disk. So I'm going to insert a floppy disk into my drive so it'll be ready to go. I'll choose yes, and then it's telling us that a log will be kept of all of the installation steps, and I'll choose OK again by pressing enter, and the installation proceeds. First we format the file system, then using all of the selections that I've made, all the packages are going to be copied from the CD-ROM onto the different parts of the file system. You can see here we have the name, the size, and a summary description of each package as we get started here. And in the bottom part of the screen we count down from the total number of packages according to what I selected in that custom list, and then it will count down and the bars will go up as the installation proceeds. Now if you selected one of the installation options such as GNOME desktop or server installation, you wouldn't have had to choose as many things as I did in this custom installation, but you would proceed right to this point and you can just watch the packages install one by one, and we'll come back when that's done. Depending on the speed of your system, your CPU, your CD-ROM drive, and so forth, the installation will take between 10 and 20 minutes at this point. Once it's finished, you just have a few more questions to answer before you're all done. We're ready to create the boot disk now. I already had inserted a floppy disk. I was all ready for this, so I'll just press OK, and the boot disk is being created. Now this can take a moment or two as we're writing out to the floppy disk. We'll just let that finish. Now we've already chosen which video card we want to use. Next we're going to finish setting up the graphical system with a few other settings. It's important that you choose the monitor carefully, because if you choose one here that has more capabilities than your monitor really has, you risk overdriving the monitor and damaging it. Again, you can press the first letter to go down in the list to that point. I'll just choose mine here and tab down to OK. Next, the X-Configurator program can probe your video card to get information from it. Now I'm going to select Don't Probe. If you do choose Probe, you may lock up your system. That doesn't happen very often, but it could. I'm going to manually select the amount of memory that my card has, and I'll tell it to not do a clock chip setting. Now if you choose to probe, it will do these things for you automatically, but this is the more detailed configuration. And I'll select my video modes. You can choose your resolution here for each of the different color depths, 8-bit, 16-bit, or 200 or 24-bit, which would be millions of colors. I'll choose OK there. Now X-Configurator is going to test my configuration. And as I warned you, there's a problem with my laptop here. You can go back and try to configure it a little differently, or you can choose Quit and work on it later. At this point, the installation is complete. We still have a few things that we'll want to clean up later, but everything is installed on the hard disk and ready to boot. So I'll choose OK, and we'll boot into our new Red Hat system. In this section, you've learned all about installing a Red Hat Linux system. We've looked at some of the prerequisites, different types of installations, how to set up your hard disk, and then walked through step by step. You could actually do an installation in between 10 and 20 minutes of your own time, depending on how fast your system is, if you're not stopping to listen to me. In the next section, we'll boot into our new system and look at some of the initial configuration things you'll want to do.